Hey guys, Rob Skiba here. So yesterday I posted this video, Flat Earth and Atmospheric Magnification. I put in there, it's a short version because I'm actually working on a video that's about twice as long. So that's just a portion from that video. And just looking through some of the comments and stuff, people were saying, "Was that must be how the sun works too?" Yes, I had already considered that and was in fact working on that when I posted this video, and so I decided that I would show what happens with the sun, and I think it may solve some interesting problems. I'll show that in this video, and I just want to revisit something before we do that, and that is the fact that there is a lot of water in our atmosphere. I went to a few websites. I just did a Google how much water is in the atmosphere, and this is the USGS website, usgs.gov, Science for a Changing World. The USGS Water Science School talks about there is always water in the atmosphere. Clouds are, of course, the most visible manifestation of atmospheric water. But even clean air contains water in particles that are too small to be seen. One estimate of the volume of water in the atmosphere at any one time is about 3,100 cubic miles, or 12,900 cubic kilometers. And it goes on to say that if all the water that's in the atmosphere were to rain down at once, it would cover the globe to a depth of about 1 inch. And this is confirmed on a number of websites, but I'll just show you one more just for the sake of argument here. This is the Y Files, the science behind the news. They have an article, How Much Water is in the Atmosphere. It says, at any moment, the atmosphere contains an astounding 37.5 million billion gallons of water in the invisible vapor phase. This is enough water to cover the entire Earth, land and ocean, with 1 inch of rain. And of course goes on to talk about that as well. So yeah, there's a lot of water in the atmosphere. I think we all kind of just know that, but I don't think we've ever really thought about what that means. And so I was thinking about that in the previous video, and so I'm going to go ahead and play just sort of some highlights from that previous video to set the stage for what I think is going on with the sun and the moon also. Here we go. But I'm thinking, if the atmosphere, especially over water, is made up of zillions and zillions of tiny convex drops of water, then collectively perhaps they all combine to make one big convex lens, in which case it would act like a magnifying glass. Okay, so with that in mind, let's look up some websites dealing with the refraction of light. You might see a graphic, something like this, showing light bending downward, just like the weatherman guy said. And here's your typical graphic showing how light rays entering some sort of medium, like in this case water, refraction causes the light to bend downward. Now we've all seen pictures of, a pencil or something in a glass of water, and how not only does refraction bend the image downward, it also magnifies it. I'm going to say that again. Water causes refraction, bending the image downward, and magnifies it. So this is important now. So now back to another clip from that previous video. Let's entertain for a moment the completely absurd notion that water is flat and it always seeks its own level. We're looking across a flat plane of water, 46 miles across. Check this image out right here. Now I caught this image shortly after Rick and I returned from our trip across the lake. We grabbed a bite to eat, and then we went out to the beach, and it was still clear out, so we got the camera out and looked 46 miles across the lake to see this right here. This image is extraordinary. Okay, the boat right here, I'm going to guess, is less than a mile away. And I base that because these people walking in front of the camera here are walking across some rocks that sort of jut out and kind of fence in the harbor area, and they are only about a quarter of a mile away from where we were when I shot this. I shot this image from right about here. This is where we were looking across, and this is the area right here where those people were walking. And the boat, as you could tell by the size of the people on the boat, wasn't too much further beyond that. So maybe a half mile to a mile, or at the most, I would say, away from where we were. All right, now when I was headed back to Chicago to catch my flight, I snapped this picture of the Willis Tower. And this is, if you go on Google Earth, this is right about the area right here where I believe I was when I took that picture. Looking across, it's only about 0.6 of a mile. So I'm just a little over a half mile away, and look at the size of the tower as compared to the car that was diagonally in front of me. We were looking at the Willis Tower from this direction right here when we were on the other side of the lake. Now, okay, so let me slide the car over and shrink it down to the appropriate scale beside the boat. Do you see something rather interesting here? This building is significantly magnified. The image on the left shows the size and scale of the building next to a car at 0.6 of a mile away. The image on the right shows the same building and the same car with a boat at 46 miles away. The atmosphere really is acting like a lens. What type of lens? A convex lens or a magnifying glass. And let's just go back and hear from the experts once again what's happening with the atmosphere.
The science is the same of that of a lens. Here's a simple example.
So if you're looking at Chicago here, just maybe now you can just see the top of the Sears Tower, and if our simulated temperature inversion moves into place, hopefully now you can see pretty much all of Chicago,
see all the lower buildings,
including what's at ground level.
So the atmosphere really is acting like a lens.
Yes.
Again, based on that imagery that I saw, looking 46 miles across versus 0.6 miles across, I really do believe that, just like the experts said, the globalist guys, these are people who believe in the globe now. They are the ones that said, hey, the atmosphere really is acting like a lens, and they put a lens in front of the camera to show how it works. So I'm just doing what they're doing. I'm using the same logic that they're using, the same science that they're using. And, science is all about testable, observable, and repeatable data, right? So to alleviate the problem of distorting the edges because the magnifying glass ring is too small, I went on Amazon and I got these plastic magnifying sheets and came up with another way of doing the same thing using the sheet right here. Set the city up, a little cutout of the city, and now I've got the big magnifying glass sheet. Bring the camera right up to the lens. See, that's the normal view of the city. Now let's back up again.
The science is the same of that of a lens. Here's a simple example.
So if you're looking at Chicago here,
the atmosphere really is acting like a lens.
Yes.
Atmosphere really is acting like a lens, and this is how much of the city is missing due to the lensing effect, the magnification of the atmosphere. You're missing a good portion of the city just by pulling my iPhone back on a 3-foot long desk. That's how much I lost of the city. And as with any scientific experiment, you always try to improve upon what you did before. So I got some foam core, made a little housing for the magnifying sheet, and pasted the city on the back there, and I made it as 2 separate pieces so that I could flex it as necessary, because I think that there are different types of atmospheric conditions that would allow for more magnification versus less magnification. So in this scenario you have more magnification, and in this one you have less. And for this one I decided to put the Toronto skyline into my little box here. And let's try it again. Okay, we're all the way up against the glass. Now let's zoom across the lake. And wow, look at that. The lower portions start to disappear. Now let's zoom back in to get a little closer to the one that Captain Baltard was talking about here. And wow, look at this. Here's his image on the right, and here's my image on the left. Missing the lower portions of the city had nothing to do with curvature whatsoever. And this, of course, is my answer to the meme that you've all seen being passed around on Facebook showing the missing part of buildings is absolute proof of the curve. No, not really. But, okay, here's the part I really wanted to show you guys. I was already in the process of modifying my experiment, so here's what I came up with. I've got my magnifying sheet frame, and I created a little stand to paste the sun on it and keep it the same height over the flat surface of a table. So the sun is always going to be parallel with the surface. And check this out. All right, here's the first test of a sun moving over a flat surface, and with no atmospheric magnification, it does what we might expect it would. It gets smaller as it goes away from us. All right, now let's see what happens when we add in our atmospheric magnification. Again, water and refraction. Water causes magnification and refraction, right? So let's bring the sun back. Oh, check this out. Refraction bends the light downward. It made the sun set on a parallel surface. As it was moving parallel, the same height, the whole way over a flat surface, the refraction caused the sun to set. Not only that, well, let's bring in the beginning of that little test, and we see that it maintained pretty much the same size, too. Pretty close. And of course, that's because as it's moving away, the magnification is still taking place. And so even though the sun's further away than it was in the beginning of the test, the magnification basically preserved the same size, and the refraction made it set. Now, I'm just going to put forward a crazy idea for you to think about. And that is, if Rob Skiba could figure this out, I'm just going to go out on a limb here. I think it's quite possible that the creator of the cosmos could have figured out the same thing and engineered our beautiful sunsets, thanks to all that water he placed in our atmosphere. Just something to think about. Thanks so much for watching. I hope you enjoyed this video presentation. If you did, please subscribe to my YouTube channel, like the video, and share it on your favorite social media sites. There's a lot more to come, so stay tuned and we'll see you back next time.